Alright, now we're going to learn how to measure front to back ratio. So what is front to back ratio? Well, it's the comparison of the signal that comes off the front of the antenna to that of the back of the antenna. So how do we do that? We set it up exactly the same way as if we were measuring beam width. So we've got the signal, we get our test antenna. Here's our test antenna. So the signal is going to come out of the output port, goes to the test antenna, travels through space to the receive antenna, back to the input port. So the same thing, you're measuring insertion loss again, so I'll write insertion loss. So what we're doing is we're comparing the signal that comes out of here to the signal that gets into here. Now, again, we're going to calibrate just like this, so that we're going to tell the analyzer when we calibrate and it beeps and it says dB, 0 dB, then we know what the analyzer, as far as the analyzer is concerned, that the signal coming into here is the same as what went out. There's no loss. And we know that's not true, but it doesn't matter because that's just establishing our reference point. So if we do that and we calibrate so that if it's like this, we say off the front of the antenna it's 0 dB, and then we rotate the antenna 180 degrees. This is now the back of the antenna. So the receive antenna is receiving the signal off the back of the antenna. And then if we just look at insertion loss, what's it going to be? Positive value or negative value? Well, it'll be negative because the greatest signal you're going to get is here. So if you calibrate and make that 0 dB, then when you rotate it like this, whatever you get off the back should be less. So let's make up some numbers. Let's pretend that for this antenna, signal off the back, we look and the insertion loss happens to be minus 17 dB. If that's the case, then it's pretty easy. This is 0, this is minus 17. Then we say front to back ratio is 17 dB. Just like that. And what this means is that the signal off the front of the antenna is 17 dB greater than the signal off the back of the antenna. And that's how you measure front to back ratio with a network analyzer for an antenna.